How about we add more functions? So far we only binded the upper movement to both pedal A and B. Now how about we bind the other movements? Let's say the down arrow, the right arrow, and the left arrow. So let's do that. I'm going to define here a function called pedal1 underscore down. So this will be the downwards movement. We are going to do the same thing. We will say y is equal to pedal underscore 1 dot y coordinates. So the first thing in order to make a movement is to read the current position, increment it or decrement it, and then update that position, right? So right here we are going to say y is equal to y plus 10. Now, I would like to generalize this as a step. So right here, I'm going to create a variable that is called the step. It will be equaling to 10, so that if I would like to change the speed of the pedal, I can simply do that by just changing the step. Because this one is indicating how many pixels would I like to move whenever I press a certain arrow. And right now it is determined by 10 pixels. What if I wanted to make the movement faster? Then I would like this pedal to jump more pixels whenever we have a step. So here this will be step. This also will be step. Now let's continue. Do you think this is right? Well, since we are moving downwards, we would like to go downwards, meaning that y need to be decremented. So y will equal to y minus step. So going up, we will be incrementing up the y coordinate, and when we are moving down, the y coordinate will be decremented down. Now we can say pedal underscore 1 dot set y, and we need to pass the new y, right? Now we need to put boundaries, the same thing we put boundaries when we were moving up so that the pedal does not go out of the screen. We need to do the same thing for the down movement. So we're going to say if y is less than minus 240 this time, right? Because the screen is divided into plus 300 and minus 300. Now we don't want the pedal to go out of the screen in the negative section since we are going downwards to the negative coordinates. Now we are going to say pedal underscore 1 dot set y to 240. And this will be my downward movement. Now let's do the same thing but for the second pedal. So this will be my second pedals. Here as well, second pedal, second and second. All right. Now, lastly, we would like to bind those with new keys. Okay. So let's say for the first player, if we press S, then we would go down. So right here, this will be down, right? And now for the second player, this will be down. And here we need to say player 2, right? So right now we have pedal 1 up, pedal 1 down, pedal 2 up, and pedal 2 down. Okay, now let us close the previous game and let's recompile. Now let's take a look. If I press S, you'll see that the pedal is going downwards. But here I think we have a bug because whenever we are reaching the end, we are going back here. Let's say Y. Yes, because this needs to be minus 240. Right now what we are saying, whenever we reach the end, we want to change the coordinate to 240 instead of keeping it at minus 240. This is why we are jumping back. So let's fix this for the other one as well. So this will be minus 240. Let's close everything and rerun the program. Now let's say S. And as you can see, we stopped at the end of the screen. If we go up by pressing W, we stopped at the upper end. Now let's try this one. This is up, upper arrow, and this is down with the other arrow. That's really good. Now we are going to create the right movement and the left movement. Let's start with the first pedal as well. So we're going to say diff pedal underscore 1 underscore right. Now let's design the right movement. How would we like to program the right movement? Well, since this is not up and down, and this will be right and left that will come next, it means that we would need to move on the x-axis and not on the y-axis. It means that we need to get the x coordinate. Unlike here where we got the y coordinate because we would like to move up and down, now we need to get the x coordinate because we would like to move right and left. So x is equal to paddle underscore 1 dot x coordinate. This will be the difference. Now, when we are moving right, we are incrementing the x-axis, right? So if this is the origin and we are moving this way, it means that x need to be incremented. So x will equal to x plus step, the same step we have defined here. And finally, we need to say paddle underscore 1 dot set. We need to put an indented block here. Here we need to set x this time, and it will be the x. Okay, so the difference between up and down, right and left is that up and down is y, right and left is x, and all the functions will correspond to x, like x coordinate and set x, unlike here y coordinate and set y. Now we need to put the boundaries just as usual, right? I'm going to be saying here if x is larger than minus 10, why minus 10? Well, let me show you. Take a look here. This is the first paddle. Let me draw it really quickly. This is my first paddle actually. Okay. Now, this paddle, when it moves right, it needs to move here. We are in the negative section of the x-axis, right? Because this is the x-axis. This is x. And we are moving along the x-axis. Now, we are moving from minus 400 all the way to the 0. Where would I like my paddle to stop? Somewhere around here, just before the 0, so maybe at minus 10. If we move a little bit further, we will get to 0, and I don't want that. I want to stop just before the 0 point. So this is why we are making sure that the boundary is at minus 10 on the x-axis. So if it is minus 10, then what I would like to do is say paddle underscore 1 dot set x equals to minus 10. And by that, we have finalized paddle 1 right. Now let's do paddle 2 right. It will be a little bit different this time, and we will see why. So let's design the paddle 2 right. Now we are going to keep this x is equal to paddle, just change this to 2, here as well, here as well. Now the boundaries will be different. Here I'm going to be saying if x is larger than 350, then I would like to set x to 350. Okay, this will be paddle 2, this will be paddle 2. Why is that? Let's take a look. Paddle 2 actually is located right here. And when we are moving right, meaning this direction, we need to make sure that we don't hit the boundary right here, right? So we are leaving some gap. Okay, so this is 400 at this point, at the last point. So I would like just to stop just before it, maybe somewhere right here. Okay, and this coordinate here would be around 350. All right, and this is why we are choosing 350 here, because we are moving right, and we need to make sure that we don't hit this boundary. I mean, unlike the right movement for this paddle where we are coming to the 0, here with the right movement of the second paddle, we are moving towards the end of the screen, right? This is why there is a huge difference between how the coordinates work in the right direction. So I'm going to copy this, paste it here. So now paddle 1 right will be using my D key on the keyboard. And paddle 2 right will be by pressing the right arrow button. So this is right. Now let's stop the previous program and let us re-execute. Now let's try the right movement by pressing D. You'll see that we stopped just before the middle of the screen. We can go up, we can go down, and the boundaries are just working perfectly. I cannot go right any further. Now let's try this one. Up, down. Let's try the right. I cannot go right anymore. This is the maximum that I can go for the right paddle right here. We can decrease this a little bit, but I think it's really good to leave this kind of a gap between the paddle and the end of the screen. All right, now let's do the last one. We need to move left. So I'm going to copy this paddle one right. Okay, I'm going to change the name here to left. And the same thing, we would like to get the x coordinate because left and right are on the x coordinate. But right now, when I'm moving left, let's take a look. Now, take a look here. When we are moving left for this paddle, coordinates are decreasing, right? Here it's 0 and decreasing towards minus 400. And I need to account for the boundaries around the minus 400. Maybe I'll stop here at minus 350, just like the one here where we stopped at plus 350, okay? It means that here we need to make x minus step because we are moving in the minus direction. And here we would like to check if x is less than minus 350. If yes, then we will say minus 350, okay? Now we will do the same thing for the second paddle. I'm going to copy this, paste it here. Second paddle. We need to change everything to the second paddle. Second and second. Now, what is the condition right here? Well, let's take a look. When the second paddle is moving left, it means that we are moving in this direction, right? The x is decreasing, correct, and the boundary is just around the 0. We will stop at 10, just like here when we stopped at minus 10 when this one was moving to the right, okay? Because we are approaching 0 right now. So when you are designing this stuff, it's really important that you draw them out and try to see how the coordinates are distributed around your window so that you can program them correctly. Okay, so here it will be when it is less than 10, and here we will say 10. Lastly, we would like to bind it to a key, so let's take this. I'm gonna copy this. Now left is using the A button, and this will be left. I'm gonna copy this as well. This will be the left arrow. And the function is called paddle to left. All right, so let's test it. I'm gonna close this, and I'm gonna rerun the program. Now let's try. If I press D, you'll see that I'm moving this way. When I press A, you'll see I'm moving this way, and the boundaries are just working as expected. If I go up, everything looks really good. I'm just pressing D, W, A, S, so it's working. Now let's try the second player. I'm moving to the left with the left arrow. I hit the boundary. I go up. I hit the upper boundary. I go down. Also hit the lower boundary. And let's try the right movement. Everything is working as expected. Let's see now, will they merge when I put them too close to each other? Yes. So they're really stopping just at the middle point right here. Okay. Alright, so right now the paddle's movement is programmed and it is working as expected.